Hi, I'm going to present how we solve this problem situation. Well, we were asked to predict the road physical conditions for the Cordoba road from an specific kilometers, but in our case, we choose 23 kilometers, that it's going from 262 kilometers till 285. First, going directly with the data, we use the physical conditions with the diagram for each gear, as we can see here, and we use the if statement to derive these conditions, and we obtain all this data. We divide the sector for the ones that we have the first data till the ones that the data suddenly disappeared. That's why we choose only this segment of the road, because otherwise our results wouldn't be that accurate. Then we do our transition matrix as well. We count how many changes from good to good, how acceptable to acceptable, and we did exactly the same for all these. And we make the sum for at horizontal and vertical to make two different types of transition matrix. But in our case, we choose the horizontal matrix because, well, I'm gonna explain this with MATLAB. For example, we have here our MATLAB. And if we did the summation with vertical matrices, our state vectors will be different than one. And this is wrong because the Markov chain model states that the summation of the vectors must be equal to one. So that's why we do the horizontal summation, as we can see here. And to see that our prediction is correct, we do the summation of the vectors, well, the elements inside the vectors, our state vectors, to see that the summation is equal to 1. And we can see here this data. And the values that are close to 1, we think that this is due to the decimals, but all the values are equal to 1. Then for the predictions for the years from 2022 till 2026, we use our last transition matrix, that is the one from 2021. And we only use this for all the different state vectors, but the only thing that we changed was our last state vector, that is, in this case, the one obtained at 2021, then 2022, it was like n plus 1. And we obtained this data. And also all these values are sum up to 1. But we see that our data is not very reliable because we didn't think that it hasn't have sense, because we can see like a very degradation due to nature. And this is kind of wrong because the rain, the cars, or all the things that are outside can't help to degrade the road. So we change our last transition matrix and we choose some educated values, like some more drastic educated values, to see more the change that in the transition matrix. And we obtain that the degradation is a lot more. For example, in this case, at the last one, we see that only the 60% goes from good to good. In comparison from our last transition matrix from the last example, it stays at 91%, but it doesn't have sense. Then going back with the document, we here explain how we solve each part of the problem situation and why we choose the horizontal summation. Also because the horizontal summation was explained on the paper that the professor gave to us, and we explained everything. And what we use, the mathematical concepts that we use was the probability vector, that they can be explained like as these ones. And then actually that ones are our transition percentage. And we use all the mathematical methods that were explained at the Markov's chain. And in addition, we use the sum of vectors to see that our state vectors are equal to 1. And finally, the results that we get is that the percentage of road in good condition dropped from 80% And then we explain this degradation for our forecast. And also, as I explained previously, we change our last transition matrix to see that our model is accurate, but when there's native degradation. This means that without maintenance. And as I explained, we have only solved for one section of the road, as we don't have like data in some points. And finally, my conclusion is that even with government investments of 22 million pesos, the roads are still visible deteriorated. And also this can be explained with the IRI values because they are like very high and it doesn't make sense. That's why our roads are like very, very bad. And going back to the problem situation, this suggests that resources may not be allocated optimally or preventive maintenance is not being prioritized over corrective interventions. That's what we explain in our forecast. In order to make visible that maintenance of roads is needed, we work with Markov chain model. The prediction of the physical state of the road at two different scenarios help us. The two scenarios are the one with maintenance, that is the one that we didn't change, and the one without maintenance, that is the one that we change. Our transition matrix that we are assuming. The predictions of the physical state of the road at two different scenarios help us to clearly show that without maintenance, as I said, road segments quickly transition to worse conditions. That's why we assume, lastly, a transition matrix. And this highlights the critical importance of timely interventions to preserve pavement quality and reduce long terms. And thank you. That's gonna be all.